In this video series, I'm going to set up a Raspberry Pi as a media center for my home television. In the last video, I went through the process of building OpenELEC from scratch, and in this video, I'll explain how we can connect and configure an infrared remote control, a regular television remote control, in order to control XBMC on the Raspberry Pi. From there, I will add more videos as I add more features to my home setup. There are many internet remote controls that are very easy to configure, but they require a device like a mobile phone or tablet. For example, apps such as the official XBMC remote and Yahtzee, the XBMC remote, can be downloaded and installed through Google Play for free. In this video, I'll set up a very simple remote control that you can build using only 3 components: an infrared receiver, a capacitor, and a resistor, which should cost you less than $1 to $2 in total. The advantage of this is that you probably have old remote controls that are lying around the house, or you could buy a cheap remote control. This means that you won't have to entrust small children with your latest state-of-the-art smartphone so that they can change their programs. The approach that I take here should allow you to use most remote controls with XBMC with the OpenELEC distribution. It may also be useful if you're using a different distribution, or indeed even a different hardware platform on which lirc is available, and you wish to add remote control functionality. So here's the physical circuit that I've created for this task. I'm using 3 pins on the Raspberry Pi: the 3.3 volt supply on pin 1, pin 6 which is a ground pin, and pin 12 which is registered as GPIO 18. You can use any GPIO pin for this task, and the figure on the left hand side describes the P1 header on the Raspberry Pi, where you can see the relationship between pin numbers and GPIO numbers. For the infrared receiver, I'm using a TSOP34838 photodiode. I did try different receivers such as the very low cost TSMP1138 infrared receiver, which is a leaded code learner. It did appear that everything was working when I tested the diode, but it gave very inconsistent code responses which weren't read consistently. When I replaced that sensor with the TSOP34838, everything started to work correctly. The first thing you should look at when choosing an IR receiver is the supply voltage. This sensor accepts a supply voltage of between 2.7 volts and 5.5 volts, which makes it perfect for a Raspberry Pi, where the GPIOs use 3.3 volt logic levels. It has an active low output, and you'll see that this fact appear when we use DMESG later within Linux. Pin 1 is an output pin, pin 2 is the ground pin, and pin 3 is the supply voltage pin. It's recommended that you add a 4.7 microfarad capacitor and a 100 ohm resistor to the supply side of the sensor to suppress power supply disturbances. So I've added these components in my circuit, and you can see them on the breadboard prototype version. I've just used male and female jumper wires to complete my circuit here, but it will be very easy to package this up into a tidier solution later. So at this point, I have my IR receiver connected to my Raspberry Pi. The data line is connected to pin 12. And the next thing I want to do is to get my IR receiver to communicate with the Pi, and for us to be able to do something with that. And we're going to use a loadable kernel module for that. But the first thing we have to do is, now that the Raspberry Pi is booted and I can see XBMC is on my television and the user interface is all present, I can now SSH into my Raspberry Pi. Log in as root. The password is OpenELEC. And we're in. We just do DMESG just for a second to see what kind of messages we received on boot. So you can see it finished with a message on DMA IRQ6 ignored, results were reset, whatever that means. So the first thing we have to do is in some way check to see, well, what do we have connected to our GPIOs at the moment. So we can do that by saying cat/sys/kernel/debug GPIO. And you can see here at the moment we only have what looks like an LED connected to pin 16. So there's no mention of the IR receiver, and nor should there be, because we haven't actually set anything up on it. What we want to do is we want to actually set up, use a loadable kernel module to actually get this IR receiver to communicate to our Raspberry Pi. And the way we're going to do that is by using modprobe. So we can say modprobe lirc RPI. So this is already pre-configured. And the input pin we want to use is GPIO 18, which is connected to pin 12. So we can use GPIO in. So the GPIO in pin for lirc RPI is going to be equal to pin 18. And if we had some sort of blaster, we could set the output pin. So we'll just set the output pin. If you wanted to, we can set it here, equals pin 1. So pin 1, okay, and let's see, does that work? So no error messages appearing. We can do dmmesg to see what happened. And we can see, good news, we can see that lirc_dev, up to here, if you remember, that's where we started. We can see lirc dev, IR remote control, driver registered, major 249. And this is already built into the current release of OpenELEC, so this is very, very easy to do. It would be much more difficult if there was no lirc implementation. Modules for stage and direct quality is unknown, you've been warned. Well, I know it works. Registered driver, input lirc as device is virtual, input 0. So that's what it's registered. That's the device that it's registered at. And auto detected active low receiver on GPIO pin 18. So that's all good news. So the next thing we want to do is, well, we want to use this mod 2 lirc0, but we're not allowed to do this. It says device or resource busy, and that's because if you do psaux, you can see that we actually have lirc running already, because, well, we just did a mod probe, so we need to actually kill that. So we can do that by saying kill all. Okay. Now if we type the same thing again, mod2 -d/dev lirc0, hit return, nothing happens. But if your IR receiver is set up correctly, I'm just using the cheap remote control, and I have it pointed at the IR receiver, and if I press buttons, you can see that we start to get messages out, and these messages describe each key press. So if I press a key, I'll press it now, press the key 0, doesn't matter, you can see that it's made up of a lot of different, if I can I go up to it? I can. You can see it starts off space, something, pulse, something, space, pulse, and effectively this is like a timing diagram to describe the particular button that I pressed. So you can see it started off with 9688089 pulse 9. Let's look at the second and third values, 9014 4508. So let's see what happens in this if we press it again. Same key. You can see in this case we get a longer space, obviously because I delayed a lot longer. Pulse 8991 4501. So 8991 4501. 8991 4501. So you can see that there's an inconsistency between the pulses and the spaces, but that's okay. We need something, and that's because of the sampling rate that we have with this receiver. This is a 38 kilohertz device. So that means that we now have a set of signals that we can get from our remote control, and we now need to move on to the next stage. And the next stage is to turn these signals into some sort of codes that we can use, or we can configure to use with XBMC. So I'll quit out of this. And the next thing, we need to go, again, this is a read-only file system, so we need to go into a directory that we have access to. And there's already, if you go into storage, and if you al, you can see there's a .config directory, cd.config. And you can see we've already got some basic setup. So for example, under remote.conf for remote control, you can see there are some configuration file setups here already. What we want to do is we want to record, and we're going to record the codes and we're going to store them into a file called lircd.conf. The way we do that is we type IR record -d dev/lirc0 and then into the current directory lircd.conf. Now this is a very useful tool. It allows us to turn remotes from any, you can read all the instructions about it, but it allows us to record and capture key presses from any generic remote control without it having to be a specific type. So I'm going to return to continue, and it says it's very important that you press many different buttons and hold them down for approximately 1 second. Each button should generate at least 1 dot, but in no case more than 10 dots. Don't stop pressing buttons until 2 lines of dots have generated. So press return, start recording. I'm going to start pressing buttons on the remote control, starting top left, and I'm just going to press the buttons, press each one a few times just to get them across. This cheap remote control, it's hard to press the buttons on it. They're kind of plasticky. Press a good few buttons until it tells me to stop. So it's trying to work out now, IR Record is trying to work out what type of format these buttons are in. Okay. Oh, I'm tired. Okay. We must be there now. Very soon. Oh. Come on. Okay, it's found a constant length. Oh, please keep pressing buttons. So I'm going to keep pressing buttons. Getting faster, getting better at it. Found some constant length 108339. At least I know where I have to get to. Okay, must be nearly there. Space pulse encoded, remote control found, signal header 67 found, possible header 90514490. I suppose that's an identifier for the remote control buttons. Trailing pulse 577. No repeat code found. Signals are space encoded. Signal length is 32. Now enter the names for the buttons. So we can enter names for each of the buttons. So I'm gonna create a set of key codes against this. So for example, key underscore up. We can key up. I'm going to use one of my keys for that. Press the button. That I only have to press it once. Key down. Sometimes you have to press this quite a lot. Okay. Key left. Left. Pick a key for left. Did that. Key right. Hold the key for the right hand side. Okay, what else do we need? That's up, down, left, right. That's important. The next one, key OK. Pick your OK, your selection key. So I'm going to pick that in the middle of the keypad. Key play, for example. These are all special. You have to stick to. Well, I'll explain that later. Key play. Oh, I never pressed enter. Oh, I did. Try again. I must have made a mistake. Key play. Press enter. Okay. Next one. Key menu. Key menu. I have a menu button. That's easy. Key back. And I can have a back button. Okay, I'm going to leave it at that for the minute. There are some more, and I'll add them to the video. We'll press enter to record, and you can see now. Oh, we have to press an arbitrary toggle bit mask. Press an arbitrary button repeatedly as fast as you can. If you see any dots, press enter. Okay, I'm ready to go. Arbitrary button, over and over again. Press as fast as I can. Okay, no toggle bit. Successfully written config file. That's what you want to see. So in here now I've got a config file. It's called lircd.conf, and we can more that. And we should see all our codes. Oh, 101%. Okay, so there we go. There's the full file. So begin remote, lircd, and here's all the flags that describes the particular remote control that we have. Gap is there, header 1, 0, and then here's the key codes that I've programmed in. So it's recorded those codes against these particular keys. And if that's all you're going to do, that's pretty much most of everything working. What I found was with the Sky remote control, I found that I couldn't get IR record to work very well. This is embarrassing. Not too bad. Must have crashed the last time. But there is a website with loads of where people have contributed already. lircd.sourceforge.net/remotes. Okay, so it's connecting, and here you can see all of the remote controls that people have already, all the makes and models of all the remote controls that people have already uploaded to the website. And if we go down here, the one that I have is Sky PQ or S Sky. So if you don't want to go through the process of renaming everything, go into Sky and you'll see there's Sky Plus. Is that the one? Revision 6. It's one of these. Let me see. Sky Plus Revision 6. So this is the one that I want. And very nicely, all of the codes have been listed against the actual keys on the remote control. Now, the only problem with this is that if you just paste this in, it won't work, or it's not going to control your XBMC, because you have to rename these keys to be in line with the keys that I just showed you. So for example, for left, right, down, up, down, you have to label that as key underscore up, key underscore down, and left, key right. And that's because there's a mapping that takes place between the keys and OpenELEC. So if we just leave the other remote control for a minute, I can minimize that. Everything is in place there. We can now check to see that it's working correctly. And the way we can do this is by typing, I think it's IRW. Let me just try that. IRW didn't work, so I'm going to reboot and see what happens. See if it makes a difference. Okay, just logging in again. Okay, we have to run mod probe again. Okay, it's back working again. Now, the event lircd is working and lirc is working here, so IRW should work. Let's try IRW, and I'm going to press my up key. Yeah, okay, so I pressed my up key, and you should see now after we rebooted, because it restarted this process, we now have our up key. Press my down key, right, left, and I can also see on my television, which is great news, is that I'm moving left, right, up, down on my television. And if I go over to videos and down to files, I'm selecting files, and now I'm able to do everything that I was before. So this is using the cheap remote control that I had before. So that means now at the moment now I have my remote control is working. So you can see the mapping of those keys, key up, key down, key OK, they're all appearing there. Now, that works very well. The problem with this at the moment is that we have to do mod probe and type mod probe to get our remote control to work. And that's not good news. So I'm going to quit out of this. The remote control is still working on the television when I press up and down the keys. But IRW is very useful now for actually debugging our what's going on in our device. So I just want to make one more change, and that's to have my mod probe load that kernel module automatically when the system boots. And because it's a read-only file system, we have to go back to storage again and cd.config. Okay, and I'm back in this directory. So we still have our lircd.conf is still present. So we want something to happen with mod probe automatically. And the way we can do this, and there may be better ways to do this. One way we can do it is to make a file called autostart. This is the way I found worked very well. Autostart.sh, and I'm just going to execute add, press A, execute /bin sh. Oops. Windows clicking in there, and add in the line okay, the same as before. So I have my autostart.sh in this directory, and we just have to make this executable. So you can see the execute bit is now set on autostart. So autostart is just very simply going to execute mod probe. Okay. So try and see that if this works correctly. I'm just going to reboot. Again, it's not returning. I don't know why that is. Okay, OpenELEC has started, so I'm going to log in again. XBMC is visible on my television. And we just type IRW. Well, let's just DMESG to see what happened. Yeah, I can see messages here. This is good news. IRC auto detect the active low receiver GPIO pin 18. So I'm pretty confident if I just hit IRW and press my button, yeah, I can see I'm already getting key changes on my OpenELEC, and it's working perfectly. It's working very well. And if I go to files, this remote control is working absolutely perfectly. For a cheap remote control, it works. I can hold it, and you can see I'm getting repeats. If I press the button once, I get one down, one down, one down. Right, right, right. Works perfectly. I wasn't so lucky with the Sky Remote, and maybe I'll just go through the process of the Sky Remote too, just so you can see when things go wrong. And it started off wrong because the IR record wouldn't work very well. So I'm just going to change it now to show you what I have to do for the Sky Remote. And maybe if you've got a remote that doesn't work very well, something like this will work for you. So I'm going to copy that, make a backup of my lircd.conf to I'll call it cheap remote control. And we're going to go through the same process, but this time with the Sky Remote control. I just want to show you this, and then I'll show you how to fix it. Oh, okay, we have to do the same thing again. Kill all lircd and try and record. Okay, and just to show you this one, now this is a different remote control, just to show you problems arising. Press turn to start recording, off I go. I thought I was pressing the buttons. Okay, I'm pressing the buttons. I can tell there's problems already because I'm pressing some of these buttons multiple times. I'm getting no dots appearing. going to be a long. Oh, come on. Found constant length. And try again, press a few more buttons. Seems to be better. Seems to be working okay. Okay. Certainly getting a better response now. Single strand. Same button. Now I wasn't asked to see if I can enter the keys this time. Same button over and over again. I'm waiting a bit between button presses to get the dots to appear. No toggle bit mask file, but I know for sure that RC6 has a toggle bit. Okay, so it didn't work. Instead, what I'm going to do is I'm going to use the website. So here I've got my file. So I'll select the text. I'm a little bit tight on space here. lircd.conf. Okay. So I just cut and paste it in. So, oops, that doesn't look good. What should be there? This config file was automatically generated. Just fill it in just to finish it. Doesn't matter, but just to be consistent. Escape colon WQ. So I now have my config file for my remote control. Now the problem is, again, we need to actually map the keys correctly, or we'll have to do this somewhere else. So begin remote, Sky Plus, DVBS, bits 8, and so on. So everything looks good, and I'm just going to map some of these. I'll give the full list of keys, but we have to, for example, oops, A. Key left, key right, key down, and this select key, and these are the center keys on the remote control. Key OK, key up, and power. I'll just try. Is it key power? I think it is. Key. And is there any others that I have to, any important ones? Back, key back. Just straighten it out a bit. Any others? Key OK, key back, up, down, escape colon WQ. Best way I've found of this is just to reboot. Okay. Everything's still working. RW. And I'm going to press my keys, my left button. Okay. I pressed it once and you can see the problem already. My right button. Oh, I've got a lot of right button press. I pressed it once and very quickly. My down button, pressed it once. And if I go into my menu here and I press it once, it moved 2 settings on my menu. One, I guess not, oh, it moved 2 settings again. It moved 3 into the right. I moved 3 to the right that time. So the problem I have is I'm getting too many repeats with this remote control. And it's given very strange effects within XBMC. The keys are jumping all over the place, and the only way I could find of fixing this, and I quit out of this. Where am I? If I go into .config and I go into my lircd.conf, there were 2 ways I found that had a positive effect on this. One was I modified my lircd. So vi lircd.conf. I had to change a few things. One was I had to add in a new line. I changed, and this is just with trial and error, suppress, repeat. I had to suppress repeat 4 and min repeat to be 1. Okay, leave everything else the same. SVPPRESS, repeat 4. And I also had to, I think it was reduce the gap, made it better for me. Okay. So that, escape WQ. I have to reboot, and there was one other thing I changed as well under advanced settings in XBMC, and you can change these yourselves. So if you go into cd.xbmc, cd user data, under advanced settings. Okay, within advanced settings, and remember I left this here before after it didn't work, the dirty redraw didn't work. In advanced settings, I have to add in remote repeat 800. Okay. When I added those values, I ended up with my control functioning correctly. So if you are having problems with multiple selections and buttons pressing multiple times, try changing those values until you get something that works correctly for you. But it means a lot of trial and error, and the easiest way to check it is just to reboot each time. It doesn't take long to reboot the system. Back in action, log in. Now, even though, I'll just wait for my user interface to fully come up. So I'm going to press my control once to the right, and it moved once to the right. Once to the left, it moved once to the left. Once to the left, it moved once to the left. Once down. And you can see this is my Sky remote, and now after making those changes, and again it was by trial and error, I have now my control working exactly to my satisfaction. If I hold the button, I'm just going to go into videos, files, and if I hold the button, you can see it's working very well, and my menus, I'm scrolling down through my menus very quickly. So I'm pleased with that now, it's working correctly. So that is it. Hopefully a similar configuration will work for you and for your remote control type. If and when I add more videos to this series, I will link them here.